Hey guys, so I have spent the afternoon playing around on Jamovi. It is actually super easy to use. I think you guys are going to maybe like it. Okay, so this is a blank screen. This is what you will get when you open it up. Your A, B, and C are variables. You may not use them all. You may add extras. So for our purposes, I'm just going to show you how to set up the data quickly. And then I've got some data sets already made. So for your pre-intervention data, so before you do any like sleep intervention or drug intervention, whatever, you're going to maybe write pre just for your data, write continue, make it a continuous variable. It's going to be numbers. It's going to change it over here to a ruler. Same thing like if you have post numbers or if you have a grouping variable. Now you will have a grouping variable since you are looking at least two different groups, your control and your treatment. And so we can put group, and I'll show you how I did it on the other. This one though has to stay nominal, so it's the three little button thingy, and then you would put your numbers in there. So let me get out of this one and I'm going to show you. Don't save. So right here, I have okay, over here under data, don't pay attention to the results section yet. These are the pre-treatment numbers. So we have 20 participants. You should have at least 20 participants per group. Ideally, maybe a little bit more, maybe 15. 20, maybe 30 per group. So this is just 10 per group. I've got 4 in so this is my treatment variable. 0 is a control. 1 is my treated with medication. These are their numbers for, say, level of, anxiety. Okay, so low numbers mean high anxiety in this case. So these are all of our pre-treatment numbers. We can run a t-test to make certain that there's no difference. So 10 of these are our control group and 10 of these are our treatment group. We do want to make certain that there's no difference between our groups. So we can run a t-test, independent samples t-test. We would put our pre-numbers up in dependent variables and we are going to group them by treatment group. Over here, we see, there is, so our p-value is actually significant. P is less than 0.05, and so we would want to see the difference in our data. It looks like I made some of the pre-numbers down here a little bit too big. So let's go, you're not ideally going to do this for our purposes. Me showing you how to do this, so I am going to do this. Okay, so that changed our data over here. So now our P is not significant at 0.857. You do not want your pre-data between your two groups to be significant. That means that your groups are not homogeneous, and we want homogeneous groups in the beginning, otherwise they're not the same essentially. Okay, so then we can do the same thing. We want to see after treatment between our two groups if the numbers changed significantly. Now, if we are treating a group, we are hopeful that our numbers have changed significantly. If we have just two groups, we can run simply an independent samples t-test. So over here we go back to analyses, t-test, independent samples t-test. Our samples are, scores on one are not dependent on scores on another, so independent. This time we'll use our post, put that under dependent variables. Again, we are looking between groups. Half of them were treated, half were not. It shows that yes, yay! Our P is less than 0.001. We only need it to be less than 0.05 in order to be significant. So we have shown that Yes, our treatment was effective in, we'd like to say reducing anxiety, but the numbers are backwards on this. Okay, so that is what you are going to do if you are doing a simple t-test. All of you should probably be running a t-test. Now, if you have more than one score, so these are, Heaven, I know for sure, is doing pre-testing numbers, post-testing numbers. You can stop there if that's what you want. If you want to add, she's adding a 9-month follow-up. We would run an ANOVA. So repeat measures ANOVA. So this is an analysis of variance. So the repeat measures, we are testing it between pre, post, and 9 months. Repeat measures ANOVA. Right here, we are going to put treatment, or label it whatever the heck you want to label it. Level 1 is going to be our pre, so no treatment to either group. Level 2 is going to be our post. Level 3 is going to be our 9-month. You can label these whatever you want to label them. When you are done, you'll see they'll all turn black. And as long as your numbers over here are in order, you can just press Shift, highlight them. Down here, repeat measures cells. So pre, post, 9-month. You are going to, well, let's look at what we've got over here. Okay, so to interpret this, there is some difference between our treatment groups. P is less than 0.001. However, since we are looking at 3 different groups, and ANOVA by itself does not tell us where the difference is, we have to run a post hoc test. So we come back over here to our analysis. Post hoc tests. We can use a Tukey or a Bonferroni. There are slight differences between them. We're going to use Tukey. Divide again by treatment. And it brings up our post hoc test right here. So pre to post, Tukey shows, so this is the number you're looking at now. Tukey is significant at 0.009. Pre to 9-month, also it is significant at less than 0.001. Post to 9 months is also significant. It is smaller than 0.05, so 0.033. So there are significant differences. We can say that there are statistically significant differences with treatment. That is what we saw up here in the independent samples t-test, that yes, there is a statistically significant difference. If we are doing repeat measures with our ANOVA, that is when we have 2 or more groups. Remember, if you have 2 groups, you can also do a repeat measures t-test, but not when you have more than 2 groups. Shows that yes, there is statistical significance. So this is going to be your within subject measurement. Whenever you run an ANOVA, you must run a post hoc test in order to figure out where the difference is. Now, if we came back over here and say at 9 months, so I kind of set this up to show, oh, I know, this was the same thing I did on the last one. We do not want a change in our no treatment group. And so we would, this is not filling in, so we would come back here to analyses, ANOVA, repeat measures, and we're just going to run this again real quick. So treatment, pre, post, 9-month, come over here. Nope, we do not need this right here yet. So it shows, Yes, there's a significance somewhere. Oh, I know, I didn't show, I was looking at the wrong thing earlier. We come over here to the post hoc treatment. I should have been looking at the post hoc and I was not. I was still looking at the ANOVA. Okay, so divided by treatment, treatment to post is significantly, statistically significant. Pre-treatment to 9 months is also statistically significant. However, post-treatment to 9 months is not statistically significant, and that is what we would expect as long as the effect of our treatment continued to have benefit. So right here we're showing pre-treatment to post-treatment. Yes, the treatment had an effect. There was also a difference in the numbers from pre-treatment to at 9 months. Follow-up, yes, it's still significant. However, there is not a statistically significant difference in our scores post-treatment, so right after the intervention, and at 9 months. It means that it's showing us that at 9 months, the treatment is still effective. Okay, that was a quick rundown of how to use the t-test, how to use ANOVA. If you are going to, you can also do a paired samples t-test, which is essentially in ANOVA. With 2 samples. This is just pre and post. It is showing that yes, there's a statistically significant difference. So if that's what your data needs you to do. This was a quick overview. It should cover everybody's data. If it does not, please let me know. Let me know if you have any questions.